In this video, we will discuss the problem allocate minimum pages. The problem has been previously asked in companies like Google and Microsoft. So let's read the problem statement here. Problem says that you are given an array of integers where each element of the array represents the number of pages that are there in the ith book, and you also have been given another integer k which is representing the number of students that are there. Now the task is to allocate the books to each student such that each student receives at least one book. So every student should receive at least one book. He can receive more than that, but every student should at least receive one book. Now each student is assigned a contiguous sequence of books. Okay, so suppose that you were giving some books to the student 1, then after that you stop giving the book to the student 1, you'll give the book to the student 2, then you cannot start giving the student 1 books again. Okay, once you stop assigning books to a particular student, you cannot repeat that student again. That is what this line means here. Now after that, no book is assigned to more than one student. So suppose there is a particular book cannot be assigned to more than one student. One book only one student will have. Now after that, the objective is to minimize the maximum number of pages that is assigned to any student. In other words, out of all the possible allocations, find the arrangement where the student who received the most find the arrangement for the student who received the most pages still has the smallest maximum. You have to return one if it is invalid. So let us discuss this very first test case that has been given to us. These are the books that we have been given and the pages inside them have been mentioned in the array. Now after that, we have been given k value as 2. So we want to assign these books to two students. Now what can be the possible configurations here? If you see, the student 1 can get the first book that is having 12 pages, and then the student 2 can get the rest of the books here, and after that another arrangement can be that the student 1 can get the first two books, student 2 can get the next two books, correct? Otherwise what can I do? Otherwise the student 1 can get the first three books contiguously and the student 2 can get this particular book. Now if you see here, what was the question? The question was asking us to basically minimize the maximum number of pages allocated to any particular student. So if you see the first configuration, if you will see the first configuration here, so what is the maximum number of books assigned to if you see the first configuration, what is the maximum number of pages assigned to any student? 191 here. If you see the second configuration, what is the maximum number of pages assigned to any student? 157. If you see the third configuration, what is the maximum number of pages assigned to any student? 113. So the question was asking us to do what? Minimize the maximum pages allocated. Okay, remember this question was asking us to minimize the maximum pages allocated, correct? So the maximum pages allocated here is 191, 157, 113. So which one is the minimum? So 113 is the minimum, so that is why it will be the answer here. Okay, you can see here that the answer for this particular test case is basically 113, because in the first distribution method, student maximum number of pages allocated to any student will be 191. In the second one it will be 157. In the third one it will be 113 here, and we have to do what? We have to minimize the maximum number of pages allocated to any student here. So that is why the final answer will be what? 113 here, because the minimum value is 113. Now how can we solve this particular problem? So we can do it in two ways. First is a linear search approach, second is a binary search. Let's see what is the intuition and what will be the ranges where we can search here. So if you can notice one more thing that is given to us, that is the rules. So every student will get at least one book. Okay, each student will receive at least one book. Each book is assigned to exactly one student, and no book is assigned to more than one student, and the students will be assigned the book in a contiguous fashion. So if the student 1 is assigned certain books, then after that you start assigning the books to the student 2, then you cannot assign the next books to the student 1 again. You cannot repeat a particular student. Suppose you use student 1, then after that student 2, then after that you cannot use student 1 again. You cannot do this. Remember this. Now if you see here, how can I optimize, how can I solve this problem here? So you have to understand one thing. Maybe you might have an intuition that let us start from 1. Let us check that if the maximum number of allocated pages to a student is 1, can this be possible? This is practically not possible for most of the test cases, because you cannot say that the maximum number of pages allocated to any student will be 1, because if you are planning to give one page maximum to any student, then you cannot allocate a book with 12 pages, you cannot allocate a book with 34 pages, you cannot allocate a book with 67 pages, correct? So if you give one page, if you're thinking that you will give the maximum number of pages as one, then you cannot allocate a book with 12 pages, you cannot allocate a book with 34 pages. So you cannot start from one, you have to be very practical here. So that is why what is the best case scenario? If you will see here, if every student is like, let's assume the best case scenario when every student would have been given one book each. Okay, although I know that I have only two students, but if we still want to imagine the best case scenario, so you can see here that if I give all the books to different students, so for this book I'll have a student one, let's say. For this book I have another student, for the next book I have another student, for next book I have another student here. Even in that case, what is the maximum value that is there? Even in this case, the maximum allocation is 90 pages. So in the best possible scenario, when for every book I have a different student, even in that case, the maximum the maximum number of pages allocated to any student comes out as 90 here. So that is why what I can say here is that initially I have to start from the maximum element of the array. You can see here, maximum element of the array is what? Maximum element of the array is basically 90 here. Correct. And the books and the array of books, it is not necessary that it is given in the sorted fashion, but you can see that the initial value will be 90 here, because even if I allocate books to different students, even in that case, one student will get this highest pages book and he will have the value as 90 here. So the maximum allocation will be 90. So I'll start from 90 here. So basically my lowest value that I need to start from is basically the maximum element of the array, which in this case is my value 90 here. Correct. Now let's think about the highest value till which we can iterate. Okay, now when will the allocation be the highest? When I allocate to only one student, when I allocate all the book, when I allocate all these pages to only one student. So if I allocate this to only one student, then it will be the sum of this particular array here. So let's find out the sum here. Let's do a basic math. So let's say this will be 46, 67, and this will be 3, 113, 90, then 3, 203. I think it is coming out as 203, but if I have made any mistakes, you can forgive me for that. Okay, now if you see here, basically we have the low and we have the high here. So the lowest answer for us can be 90, the highest can be 203 here. Now if you see, I'll try to do what? I'll try to check. Can 90 be my answer? Can 90 be my answer? Can I allocate 90 pages maximum to any student and I can do my job? If you see here, if I give 90 pages, if I allow not more than 90 pages for a particular student, then what will happen? Now if you see here, student one will be able to do this. Okay, student one will be able to take this also, and then after this, can the student one take this as well? I think so he cannot. The reason for that is because it will exceed the 90 limit. I cannot allocate more than 90 pages, so that is why student one will have to stop here and I need to start with student two. Now once I have given this 67 to student two, can he take this next book 90 also? No. So I need a student 3 here. So if you see here, what is my counter here? My counter comes out as 3. So for if I am allowing any student to have maximum if I'm allowing any student to have maximum 90 pages, in such a case, I need 3 students. I need 3 students. But how many I have? I have only 2 students. So this means that this is not possible. If I am assigning maximum 90 pages to any student, in that case, I cannot assign the book to both the students here. I cannot assign all the books to only 2 students. So that is why I need to increase my value. So I'll check for the next value, because when I thought that I'll give not more than 90 books, when I thought initially that I'll give not more than 90 pages for any student, in that case I need to take 3 students, but actually I had to distribute this amongst 2 students only. So if I'm taking more students than I was allowed, in that case I have to do what? I have to basically look for the next value, because 90 is not able to satisfy the criteria. With the value 90, I'm not able to allocate the books to only 2 students. I am requiring 3 students, so I need to check for some other value. Now when I'll check for so I check for 90, it is not working. When I'll check for 91 also, it will also not work. So on and so forth. When I'll check for, let's say, 112 also, will it work or not? Let's see. If I check for the value 112 here. Now if you see, if I'll check for the value 112 here, so initially S1 will get this, S1 will get this as well. Let me think if S1 will get the next one also or not. So 34, this will be basically 46, then 67, this will come out as 113 here. So you can see that, can I allocate this book also to S1 student, to the first student? No, I can't, because if I allocate this much, then it will be more than 112, but I cannot give more than 112 books. I cannot give more than 112 pages to any student here. So that is why what I need to do here is I need to assign the second student to the next book. So S2 will be assigned here. Now after that, can the S2 student take this as well? No, because this will be more than 112 here. So I cannot give more than 112, 112 books, 100. I cannot give more than 112 pages to any student. So that is why I need a third student here also. So you can see that I am again requiring more students than I was given. So this means that 112 is also not my answer. Now after that, next time what will happen, when we'll iterate again and we'll check for the next value. So the next value will be basically 113. We'll check for 113 whether it can satisfy or not. So if you remember, S1 will be here. S1 will take this also. S1 will take this particular book also. So total pages assigned to the S1 student will be here what? If you see 113. So this is completely fine, because if the maximum I'm thinking of is 113 here, I'm thinking that maximum I'll allocate not more than 113 pages to any student, and here S1 student got this much. Now after that, S2 can get this. Now, was I able to allocate books to only two students if I allocated not more than 113 pages to any student? Yes, I was able to allocate all the books to only two students, with the consideration that any student with the consideration that the maximum number of books allocated to any student is not more than 113 here. So this satisfies my criteria. So 113 is the very first element that satisfies my criteria. So this is where I need to stop here. This is where I can break away and I can store this as my answer and I can break away. The reason is because I want the minimum value. Okay, I want the minimum value. I want to minimize my maximum number of pages that are allocated to any student. So I'll stop here and I'll break away. So what is the time complexity of such an approach? Because you can see that we were linearly iterating, and for one particular page allocation, we are iterating throughout the array and checking every time. Okay, so for one particular allocation, if you will see, what we are doing is, let me just make some space here. So if you will see here, the thing is that for one particular allocation, we are iterating throughout the array and we are checking that whether it is possible or not. So in the worst case, we are iterating how much? We are iterating through the range. So we are iterating through the sum of the array minus the maximum element. So basically the range is what? How many elements are there in that loop? Initially we start from the maximum element and we will end at the sum. So the difference will be sum minus maximum element of the array here. So for this much, if we are iterating, so it will be order of n into sum minus max here. Now this complexity is very high because obviously it's a linear search. So for one particular value when I'm checking, I'm taking order of n time here, and overall if I'll iterate throughout the range by doing a linear search, so I'll iterate sum minus max times, right? So the overall complexity will be n into sum minus max here. Okay, now let's look at the code also. If you will see the code for the linear search, so one thing that we have to check is the edge case. If the number of students are more and the books are less, for example, suppose that there are three students that we have. Okay, suppose that we have how many students? Suppose we have got three students. Okay, and we have got only two books. Okay, so can we give at least one book to can we give at least one book to all the students? No, I cannot. So in that case, we have to return -1. That if the number of students are more compared to the books that we have, in that case, we cannot give every student at least one book. So we have to basically return -1 in that case. Now, if you see here, initially, you can find the lower range. So my lower range will be initially equal to the maximum element of the array, and my higher range will be equal to the sum of the elements of the array here. Now, after that, what we will do is we'll iterate from this lower range till the higher range. That is, we'll start iterating from the maximum value of the array till the sum of the array. That is what I had told, because I told you that we have to start from 90 and we had to keep on iterating till 203. But if we find any value that satisfies, then we can stop there. So because we want to find the minimum value amongst those values as well that satisfy. Now after that, if we check the ith value here and it satisfies, right? If we are able to allocate maximum I books to any student and it satisfies the criteria, in that case we can return the I value. Otherwise, if we iterate throughout this for all the values and we are not able to get any answer, then we'll return -1. Now what have we written in the check function? Check function is the same function which was helping us to iterate throughout the array. So if any array was given to us, the check function was telling us that how many students are we taking if we have a particular page limit at that point. So if we have this much page limit, that we will not allocate this much more than this much pages to any student. In that case, how many students are going to get the books? So the thing is that initially the count will be 1. Initially will be at the very first student, and the pages allocated to that student will be 0 here. Now after that, what will happen is we will check what? We will check that if the number of pages allocated to the student so far plus the number of pages that I'm planning to allocate right now, if it is greater than the limit, in that case I need a new student. So I'll say that okay, I'll increase the counter and that new student will get this particular ith element. Okay, so let's have a look at this. Suppose guys that I have got something like this here, and then I have got something like 15, then I have got, let's say I've got this much array here, and my limit is how much? My page limit, let's say, is equal to nothing but, let's say, 60 here. Okay, now what will happen? Initially my count will be equal to what? 1. I'll be at the very first student. And the pages that have been allocated, let's say page sum, will be initially equal to 0 for the starting student. Now if you see here, student 1 will be allocated this, fair enough. So can I allocate this much? Because 0 plus 12, is it under control? Is it under 60? Yes. So I can allocate. So student 1 gets this. I'll go to the next student. Now plus 40 will be done here to the, I'll check by doing plus 40. It will be 52. Is it under control? Is it under the limit? Yes, it is less than equal to 60. So student 1 can get this book also. Now after that, 52 plus 15 when I'll do, so it will be what? It will be 67. Now can I allocate 67 pages to the student 1? No, because it is beyond my page limit that I have taken as of now. So in that case, I need a new student. So I'll say that now I need to do what? I need to update my count to 2, that I need a second student, and my page sum will be equal to this particular ith book that I'm at. So it will be basically 50 as of now, and student 2 will get this. So this is what the code is doing here. And if my counter is what? If my counter is less than equal to k, so if I can assign those books to k student or less than k student, then it can be assigned to exactly k students. Okay, because if I take a particular limit and I can do it in I can assign those books with a particular limit. If I can assign those books to k students or less than k students, if I assign it to less than k student, then also it is fine, because if I am assigning it to less than k students, this means that I'm giving more than one book to a particular student, so even that is fine. Okay, that is why we are using the less than sign, because suppose that there was a test case like this. Let's say we had 10, 20, let's say we had something like 30 here. Okay, and the k value, let's say we had something else also. Let's say we had something like let's say 15 as well. Okay, and my k value was equal to what? 4 here. Suppose that I had 4 students, but if I had kept my limit as what? Let's say if I had kept my limit as something like, let's say, 31 here. So what would have happened in this case? If I would have kept my limit as 31, then in this case, suppose that as of now my page limit is equal to 31. I'm planning to assign not more than 31 pages to any student here. So what will happen is, if you see, student 1 will get this, and student 2 will get, student 1 will get this, and then the student 2 will get this, and the student 3 will get this. And the count will be equal to what, guys? The count will be equal to basically 3. Now you will start telling me that I have given the books to only 3 students. How is this valid? Again, think about this. If I can give the book to less than k students, then I can allocate to k students also. That is fine, because initially I've checked that whether I can assign at least one book to every student or not. In the base condition, in the if condition, I had checked this thing while I was here. So understand one thing very clearly, that if my count is less than equal to k, this means that it is possible to assign the books to k students, because here in this case my count shows 3. That if I kept the page limit as 31, suppose that if I kept the page limit as 31, then I can assign the book to 3 students and I can do my job. But the k value was 4, and you can see here that, in this case, if the count is even less than equal to k, in that case also, like, every student is going to get a book here, and it that will not be more than 31 pages. So that is why if the count is less than equal to k, then we will return true here. So this is why we are checking less than equal to symbol here. But if the count is greater than k, then we need to return false, because I had initially told you that whenever the count is becoming greater than k, then we need to basically, when the number of students are more, when the count of the students that you are assigning is more than the k value, the given number of students, then you need to stop there, because that is not a valid allocation. If you're taking more students, then what is the number of students that is given to you here. Now after this, your code will be fine, and this check function will be completed, and if it is returning true, if you can allocate the pages to k or less than k students, then you can always allocate the pages, you can always allocate the book k student. At least every student will get one book each, at the bare minimum. So return this ith index here, otherwise return -1. Now if you will see here, can I do it more optimally? Yes, I can do it more optimally using the binary search approach. How? So the logic is, again, if you see, my low will be what? My lowest will be equal to the maximum element of the array, that is 90. Now my high will be equal to what? My high will be equal to the sum. I think that my sum was coming out as 203 here. Let's quickly write this as 203 here. Now what will happen here is, so yeah, my high is 203 here. Now after this, what will happen here is, we'll calculate the midpoint and we will check. Initially, we'll update a answer variable also. We'll have an answer variable also. Now we'll get the mid. Now what is the mid here? So 293 will be the sum, divided by 2, it will come out as 146 if I'm not wrong. Let me check. 1 4 and then I'll get what, 13, so this will be 6. So let's say if I get the mid as 146 here. Now you know one thing for sure, that like the answer was actually equal to 113. If you remember, the answer was equal to what? It was equal to 113. So will 146 satisfy as a mid or not? Yes, it will satisfy the criteria, because if you see here, student 1 will get this, student 1 will get this, student 1 will get this also, and I think after that I can allow this to student 2. So if I keep the maximum allocation for any student as 146 pages, right, then I can allocate the pages properly. So in this case, 146 satisfies my criteria. If it is satisfying the criteria, I'll update my answer with this particular mid. Now understand one thing: whatever mid satisfies my criteria, should I be happy about it? I should be happy. I should store it. But the question is asking me to do what? The question is asking me to minimize the maximum allocated pages to any student. Minimize the maximum allocated pages. So if I'm saying that, if I'm saying that mid is able to satisfy, this means that if I allow 146 pages maximum allocated for any students, I'm able to satisfy my criteria. But I want to bring this number down. So where should I search? I should search on the left side of mid. So that is why I'll do what? I'll search on the left side of this mid. So I'll update the high as mid minus 1 here. So what I need to do is, I need to update my high as now 145, because if I can do it with 146 pages, if I can allocate 150, if I can allocate maximum 146 pages for any student, and I'm able to distribute properly, I'll try to check, can I do it in lesser or not? Can I do it in lesser or not? Because I want to minimize my maximum allocated pages here. Okay, so now what will happen? Now if you take the sum again, so this will come out as what? 235. Okay, now you divide it by 2. What do you get? You get 1 1 and then 1 1 and then 7. So suppose that you get 117 as the next mid. Now what will happen when you get 117? Now if you get 117 here, will 117 also satisfy the criteria? Obviously it will satisfy, because if like actual answer is 113, you know, for this. So 117 will 117 will satisfy the criteria. So you will say that, okay, I'll update my answer with this particular mid now. So answer will be now 117, 117 here. Now after this, what is going to happen here is, if I'm able to do my job with 117 maximum pages allocated, I'll try to reduce this. I'll try to search on the left side of this mid, because I'll try to minimize my maximum allocated pages for any student. So we'll search on the left side of mid. So now high will be equal to 116 here. Now, what is the midpoint that I get at this point? If you see, so the sum will be 206. If I divide this by 2, so it will be 103. So now the mid will come out as 103 here. Now, can I do it with 103 pages? Can I allocate 103 pages maximum to any student and I'll be able to do my job? No, because if you see, student 1 will be here, student 1 will be here, then the student 2 needs to be here, and student 3. So I'm taking more than k students. So this 103 will not satisfy. If a particular mid does not satisfy the criteria, then I need to increase my searching space. So if 103 is not able to satisfy, then anything before 103 will also not be able to satisfy. So I need to search on the right side of mid. If the mid is not satisfying the criteria, I need to search on the right side of mid. So update your high as what? Mid plus 1. So it will be basically 4. Once you keep on searching by search like this, if you keep on doing like this, then the mid value will be equal to, at one point, it will be equal to 113, and you'll update the answer as 113 also. And then after this, your low and high will cross and you will basically stop. So as I told you that if what happens is, if you check for a particular mid here and it gives you true, that you that you can give maximum mid number of pages to any student and you are able to do your job, then in such a case you will say that, okay, let's store the answer as this particular mid, and we'll search on the left side of this mid, because we'll try to reduce our search space. So we'll update the high as what? Mid minus 1, because we'll try to minimize the maximum number of allocated pages. Otherwise, if the mid is not able to satisfy the criteria, then we need to increase. So we need to update the low as what? Mid plus 1. We need to, if the mid is not able to satisfy, anything before mid will also not be able to satisfy. Anything before mid will also not be able to satisfy. So we need to search on the right side of mid. Okay, so low is equal to mid plus 1. So this is what we will do in the binary search overall. Now, if you see here, like the check function will be the same as the previous problem, because initially what you will do is like you'll update the counter as 1, pages will be 0, and you will check that if the current student that you have, if whatever pages he has read plus the current uh, pages of the book, if I add this and it is exceeding the limit, then I need a new student, and that new student will read the pages of the ith book that are there in the ith book. Okay, and otherwise, if the current student itself can read, then I don't need a new student. I'll update the page count for the current student itself. And at the end, I need to check that if my count is less than equal to k, then things are fine. Everything is satisfied. Now, after this, if you will see here, so we have a find function here. That the check function will be the same, because for one particular mid, what I'll be doing for one particular mid, I'll be applying the check function now, whether that mid satisfied or not, satisfies the criteria or not. So I'll take how much time? I'll take order of n time. Now, if you see, we'll be running a binary search. So it will take how much time? It will take log of sum minus the maximum here, because the range here is sum minus sum, like from maximum element of the array till the sum I was checking in linear search. So the binary search range will be the difference of these two. Okay. And then you can see it will be log of sum minus maximum. Okay, so the complexity will be n into log of sum minus the maximum element of the array. So now the complexity is roughly what? It is like n into log m here. Okay, let's assume this figure as m. So it's like n log m. So the complexity is reduced now. Okay, let's see the binary search code here. So if you see, if k is greater than the number of, if the number of students are more compared to the books, then return minus one. Otherwise, what you do is, like, initially low will be equal to what? Maximum element of the array. High will be equal to the sum of the array elements. And then after that, initially we update the result as minus 1. Suppose if the answer is not possible, then the result will be minus 1. Okay. Now we will iterate low is less than equal to high, and we'll calculate the midpoint. Now after that, if the mid satisfies, so if I'm able to allow maximum mid number of pages allocated, if I'm able to allocate, like if I keep a constraint that I will not give more than mid number of pages to any student, and that mid satisfies the criteria, and I'm able to do my job, that by allowing not more than mid number of pages, maximum allocating mid number of pages to any student, I'm able to satisfy my criteria, then store this in the result, and we'll try to bring this number down, because we want to minimize the maximum number of allocated pages. So we'll search on the left side of mid. So high is equal to mid minus 1. Otherwise, if this mid is not able to satisfy my criteria, and like in that case, we need to increase, because if by allocating maximum mid number of pages for any student, I'm not able to satisfy the criteria, so anything before mid will be of no use. I need to search on the right side of mid. So update the highest, like update the lowest, mid plus 1 here, and at the end you will just return the result here. So this will be the binary search approach. I hope you have understood this, and as I said initially, this problem was asked in Google and Microsoft. So I hope that you know how you will explain this in the interviews and write the code as well. Let's quickly submit the code and see if it is getting accepted or not. So let's submit the code now. So you can clearly see that the code is getting accepted. I hope that you have understood this particular problem clearly. Make sure to comment understood. Thank you for watching this video.